Okay, so tonight we're going to go through basically the machine learning model building process, which means that we uh, have something we want to predict, and we have some data to work with. We're going to split our data into training and test parts. And we build the model on train, and then we test the model on test. And we do that for a bunch of models, and then we look at how the models perform in predicting the test data, not the training data. We don't want to evaluate models using the data which was used to build them. We want to evaluate models using data that they didn't have to look at when they were built. Okay, so let's get into this. So the thing we're trying to predict is how much weight people want to lose or gain. And what we're going to do, we'll go back to the data frame that I used the first night of class to illustrate sample data analysis. And I'm going to include some parts of that presentation here, although I'm just going to kind of skip over them quickly and note what was done. And then we're going to get right to business on the model building process with this thing. So the data is cdc.r data, and it's sitting in Moodle for you. And this is something important. We need some packages. We need Broom, ggplot2, dplyr, and we're also going to be working with formulas. So we need this package formula.tools. And I'm sure you'll have to install that one because we haven't used that one before tonight. Okay. And then this is the stuff that came from before in the sample data analysis. We look at all the variables in the data frame, figure out what they are. And we've got weight and weight desire, and height, and that's what's going to enable us to build a model describing how much people want to lose. And we're going to have to use the concept of BMI because it takes into consideration both the weight that a person has and the height that a person has. It means an awful lot different if you have a 5-foot tall person who weighs 120 pounds and a 6-foot tall person who weighs 120 pounds. Okay? So here's all the new data that we create. We have to create BMI itself, and then we create desired BMI based on the desired weight. And the thing that we're going to work with is the desired to actual ratio. This is really the thing that we're going to use as the thing we're trying to predict in our modeling process. Okay. And then there's some stuff that I did before on cleaning the data. We got rid of some really weird people. What do I mean by weird people? Well, as a person who thought they were 7 foot 9 inches tall, another person who wanted to weigh 680 pounds, and some people who wanted to have a BMI of greater than 50, and that doesn't make much sense. 40 is morbidly obese. I mean, what do you want to be? Or a BMI less than 10. I don't think it's possible to survive with that kind of BMI. Okay, and then here's the step where I remove some data from the original data frame. And I'm just going hurriedly through this, but I want to make the point that whenever you start a modeling process, the first thing to do is to look at the data and get rid of the bad parts of the data. There's always something funky about every data set. Okay, now we get down to the real work for tonight, splitting the data. We want to split our data into train and test. We'll build the model on train, evaluate its performance on test. So randomly select about 75% of the data for train and 25% for test. And I want you to follow the process in the supervised learning course done by Mountain Zumel in DataCamp. And I'm sure that you should have done that by now. Okay, well, I'm going to stop the video and let you, you're going to stop the video and you're going to go do your work. And then after you've done your work, you're going to come back here. And you can follow the same exercise as it was done in DataCamp and almost just change the variable names and everything works out. Okay? Okay, you're back. I assume you finished your work. So first thing to do is see how many rows do you have. Almost 20,000. Then we create this thing, GP, which is that number of random numbers selected from the 0, 1 interval. And then we pick train if the corresponding value of GP is less than 0.75, and we put an observation into test if the corresponding value of GDP is greater than or equal to 0.75. And then we use n-row on train and test to make sure that things came out roughly right. And yeah, that's just about 3/4 and 1/4. Okay? So let's see, what do we do next? Task 2, Model 1. Our first model. Focus on predicting desired actual ratio. For our first model, we use only BMI as a predictor and create LM1 using train. Then use tidy and glance to examine it. Store the formula in the glance data frame, which you should name glance1. Use LM1 to create the variable pred1. Notice that everything has a suffix of 1 in this exercise when we're working on model 1. And that's an organizing principle that we're going to use to compare models at the end. So stop this video, go ahead and do that work, and come back when you're done and see the way I did it, all right? Okay, you're back. I assume you did your work. So this is the way we're going to do this thing to keep this label. You may not have done this exactly this way. You probably just put the formula in here and never really created it as a separate formula. This is Nina Zumel's style of doing things, is to create the formula separately and stick the formula in here by name into the model. Okay? And tidy1 is then tidy of LM1. Notice that tidy always produces a data frame. So we'll stick the results of the tidy computation into a data frame called tidy1. And then in that data frame, we'll stick the formula. Now, if you try to stick the formula in here by itself, it won't work. What you have to do is convert it to a character string. And the function that you need to convert a formula into a character string is ask.character, which is in that library formula.tools, which I said we're going to have to use tonight. Okay, then you could look and you can see that the desired actual ratio actually winds up in tidy1. Okay, then we do the same thing with glance. Glance is glance of LM1, glance1 is glance of LM1, and then we stick the formula as a character string into glance1, and we look at glance1, and we've got all these numbers. And then the last step that we need, we're going to use the predict function with the model LM1, but we're not going to apply it to the original data. We're going to apply it to the test data. Remember that LM1 was built using train, but this is where we see what it does with the test data. So we have to stick in the test data frame, we'll stick the results of this exercise as pred1. Okay? So take a look at that, make sure you got it all right. Task 3, create an R function, RMSE, root mean square error, with parameters predicted and actual to compute the root mean squared error. We will use this to compare the performance of our models on the test data. And that's what is reported as the value sigma from the glance output. So use the function to compare the actual and predicted values in the test data frame and save the result as test underscore RMSE in glance1. Okay? Stop the video, go do your work, and come back here and restart the video when your work is done. Okay, you're back. I assume you got your work done. So let's take a look. So Here's the function which has parameters actual and predicted, and within the function we create residual as the difference between the actual and predicted. And then these is what you might call the errors. So we square the errors, and then we take the mean of the squared errors, and then we take the root of the mean of the squared errors, and that is what we return as the RMSE, the root of the mean of the squared errors. And then in glance 1, we want to put test underscore RMSE. It's the root of the mean of squared errors based on the desired actual ratio, the actual value in test, and the predicted value from model 1 in test. And that's what gives us glance 1. And if you push out far enough, you can see all of that. Okay. Task 4, create a model LM2 by adding the categorical variable gender to LM1 and store the formula in glance 2 as you did with model 1. Go ahead and do that. This video stopped, right? You've stopped the video, okay. All right, you're back. Let's see how that's done. So FML2 just added gender to the list of variables on the right-hand side of the tilde. And then LM2 looks exactly like LM1, except that in here you've got FML2. And again, data is trained. Tidy2 is created just like Tidy1 was created. And Tidy2 gets the formula, FML2. And then you could print out Tidy2. More importantly, for our comparison purposes later, glance2 is glance of LM2. And glance2 $formula is as.character FML2, glance2. We look at that. So task 5 is to examine the performance of model 2 on the test data using the function we created and add the results to glance2, just exactly like we did for model 1. Okay, I'll stop, pause the video while you work on that. Come back and restart the video when you're ready to go again. Okay, you're back. Let's see what happened. So test $pred2, note we have to put the suffix pred2 here to distinguish it from the column test pred1 that we put in test. And to get test $pred2, we use the predict function with the model LM2. And of course, the new data is test, just as it was with when we created pred1. And then we take the root mean square error of the actual value and test $pred2 and stick that in glance2 $test underscore MSE, RMSE. Okay? Okay, task 6. This is getting easier by now, probably. Repeat the exercise for a third model by adding Gen Health. Do everything in one step. Okay, a lot of work to do here. So stop the video. Maybe it's time to take a break, get a cup of coffee, maybe get a beer, whatever you like to do when you take a break. If you feel like you need to take a break now, you probably do. But anyway, stop the video. And don't start the video again until you got your work done, until you've given up completely. But you're not going to give up now. You've already learned so much of this stuff that it's getting really, really, really easy, I think. Okay, you're back. Let's look. FML3. We have BMI, gender, and Gen Health on the right-hand side. LM3 just uses FML3, same data set. Tidy3 is tidy of LM3. And Tidy3 $formula is as.character of FML3. And here's Tidy3. Notice it's got all the parameter values. The most important thing for comparison later on, however, is glance3. So we put glance3 is glance of LM3, And glance $3 formula is s.character of fml3. And test $pred3, note the suffix 3 is predict based on lm3, where the new data is test. And then glance $3 test under RMSE is the RMSE of the actual value, desired actual ratio, with test $pred3. And then we can print out glance 3. It's not really very readable. And this slide making software doesn't do a real great job of displaying stuff. Sorry. Okay, well, let's go on, but you see how to do this, right? So look at this thing, make sure that you understand what I did here, because we're going to do more of the same later on. This is kind of a standard workflow. Okay, Model 4, similar to Model 3, but the third variable is age cat instead of gen health. Repeat everything and produce glance 4 for comparison, and of course do it in one step. Okay, so at this point it's really a matter of just copying the model and doing some text editing. So stop the video, do your work, come back and restart the video when you're done. Okay? You're back. I assume you're done. Let's take a look. There's 4, that suffix, and you notice that we've got gender and age cat. And 4, 4, 4, 4, 4, 4, everything. This is really, except for this, the only editing was to change the 3s to 4s. Okay? And again, the same thing down here. The only editing really from the last process was to change the 3s to 4s. Okay, and now you've got glance 4 saved away. Okay. What do you suppose is going to come next? Try to guess. Well, okay, I want you to create Model 5. Include gender, gen health, and age cat in the model and run everything to produce glance 5. Okay. I will stop the video while you edit the code from the previous section and change all the 4s to 5s. It's really about all it amounts to now. Okay, you're back. I guess you got the 4s changed to 5s. Let's take a look. Yeah, there's a 5, a 5, a 5, a 5, a 5, a 5, 5, 5. And I got both age cat and gen health in addition to gender. Okay. Okay, let's go on and do something else. Task 10, Model 6. So far we've always included gender as one of the categorical variables. In Model 6, drop gender, just include gen health and age cat, or a BMI, of course. We always keep BMI in the model, but drop gender. And repeat all of the steps and produce glance 6. Okay. Not too much work, basically the editing, changing 5s to 6s and changing the actual formula. So stop the video, get that little bit of work done, and come on back here and let's hear what I have to say about it. So here's the 6, 6, 6, 6, 6, 6, 6, 6. And you see gender is gone. We've just got age cat and gen health here. Okay. And now we put glance $6 test underscore RMSE. Build that thing with the RMSE function. And we could look at glance 6 if we wanted to. And again, Sorry, this thing doesn't do a really great job of displaying data. Okay, let's go do something else. Task 11. Now the fun part. This is where we get to see something, kind of the last stage of model building. And we're going to use RBind to combine Glance 1 through Glance 6 into one data frame. And Glance produces kind of a wide data frame, so I want to keep only the formula and the test performance statistics and use arrange to order the data frame by test underscore RMSE, and then decide which model is best. Okay, so this is not exactly a simple editing job. It's fairly simple coding, but it may take you a few minutes to do it. So go ahead, stop the video and go do your thing, and then come back and we'll talk. Okay, you're back. So all 6 is RBind of this list of things. And then, having built all 6, you select formula and test underscore RMSE, and then you arrange it according to test underscore RMSE. And now you have your models ranked from very best to worst. And the best model is the one which had all of the variables in it. And let's see what happened when we dropped gender, when we just had age, cat, and gen health. This was model 6. Notice that age, cat, and general health really don't add a whole lot to the model. It dropped the root mean square error by only a very minor amount. The big change comes when you put gender in the model. Then your root mean square error drops to 0.066. And after that, it's really the changes, the other things that you include along with gender only have effects out here in 10 to the minus 1, 10 to the minus 2, 10 to the minus 3, 10 to the minus 4, like they're 1/10,000th different, all the way from 2 to 8. The big thing is that you need a gender. Okay. Graphics. Oh, yeah. We got to do graphical evaluation. We want to look at the relationship between predicted and actual values using ggplot2. So we'll use the data frame test with the predicted values from the best model. It was model 5. And use ggplot2 to make a scatter plot of the actual and predicted values. Of course, you map the predicted values to X and the actual values to Y. Set alpha to 0.1 in your geom_point, and add the line y equal x using geom_ab line and color it red. That's the line that's where you would be if your actual ratio was if your desired ratio was your predicted ratio was the same as your actual ratio. And then add a default smoother using geom_smooth and color it blue. Note what you see. Okay, so I think it'll take you a few minutes to get that done. So play around with that. And when you're done, or when you give up and you're ready to look at what I did, come back and look. All right? Okay, so you're back. You must be done, or you've given up. Let's take a look. So I start with test, and then I do the ggplot. I map x gets pred 5, y is the desired actual ratio, and then I have a geom_point with an alpha of 0.1, a geom_ab line with a color of red, and a geom_smooth with a color of blue, and I added a title performance of model 5. Okay, so ponder this graph and think about what you see. What do you see? Well, the strongest thing that I see is, well, it's not the thing that catches my eye most, but from the modeling perspective, what I notice is that the geometric or smooth is at the end reaches way up above the red line, or it's going distinctly above the red line. And here, right here is where you have a desired a ratio of 1. Okay, this is where you actually successfully predicted your prediction was that the ratio would be 1. And after that point, what it says is when you have even higher predictions than that, that for those higher predictions above Pred 5 is that you weren't high enough, that there's something else. There's a bunch of points up here, and they typically occur above where you have a prediction of 1, and they're even larger than you thought they were going to be. The other thing that I notice is this really strong cluster of points, which is where you have a true desired actual ratio of 1. This is the bunch of people who just say that their actual weight is their desired weight. And notice that that has quite a good-sized range all the way from about here out to here. There's a whole lot of these people. You can see this kind of solid line fitting in even with an alpha of 0.1. And that would be an interesting aspect, maybe a choice model to say what are the characteristics of people who really express no desire to change their weight at all. Okay, well, that's the end. That's the last slide for tonight. Okay. So